And we are live. Hi, everyone. It's Gregor Sutty here again, Azure Greg. And tonight I am going to be streaming with a guy called Tori Nestenius. And we're going to be talking about some software that he's written that's open source. And he was chatting to me a wee minute ago about it. It's called the Cloud Debugger. And he's going to be doing a talk about that. And then he's also going to be doing a little bit of a talk about default Azure credentials. And we're going to do a deep dive. So without further ado, let me add Tori to the stage. Tori, good evening. How are you, sir?
I'm also fine, and you?
Yeah, I'm good. I'm good. Where are you joining from tonight? Where do you live?
From Helsingborg in Sweden.
Oh,
So
Helsingborg. Very
yes,
nice.
so it's you know equally, I guess, equally cold and dark weather as your place, I guess.
Yep. Tell me a little bit about yourself. What do you do as a job? What's your background? And
So, so let's kind of start introducing myself. So my name is Tor Nestenius. I've been programming since I was like 10, 11 years old. One of the biggest things I did in the past was I created my first website in 1996, and it became a site called Programmer 7. It was actually my full-time work and job for like 8 years between year 2000 2008, doing everything from marketing to sales to development to administration to deployment to SEO to everything. So that was my kind of full-time living for many years. I also like to help others, so I really kind of appreciate, and think it's really fun and good way to learn myself to answer other people's questions. So I've been mainly focused in the area of authentication, OpenID Connect, things that people think are really hard and complicated. In my kind of youth, when I was young, back in the Stone Age, I did a lot of kind of game development for the Atari ST home computer. I was part of the demo scene, making demos for the Atari computer. I even thought that everybody wants to make games, but games for Atari, Amiga, or PC kind of it's for amateurs. The real developers do console games like Nintendo, Mega Drive. But as a kid that is kind of 20, 21 years old, you don't have any money, equipment, or money, or company or license. Really wanted to develop for the Sega Mega Drive. So I actually built my own hardware developer kit here that actually worked. But I could actually download binaries from the Atari ST computer onto the Sega Mega Drive. And if you want to read more about that project, it's on my blog that I can present in a bit. And besides that, I also co-created a sound tracker for Atari ST computer called Audio Sculpture in 1991. So it's kind of way back in those days. So I actually have this kind of box with floppy disk and manual, and the shrink wrapped and everything. So it's funny. Besides that, so in my day job, I work as a freelance teacher, instructor, consultant. So I do coaching and instruction and teaching developers at companies, mainly in the Nordic countries, but also abroad. And I do focus on a lot of different topics, everything from architecture, CQS, event sourcing, down to OpenID Connect, authentication and web security, and also a lot of .NET, both from beginning things up to the really in-depth advanced things. And all of those courses I developed myself because I really think that, an instructor should teach his own material to really ensure that you can, have the best quality. And so that is my kind of day job. I do teach and instruct and coach people in these kind of topics, and hopefully maybe in Azure in the future. I do also blog. So my blog, nestenius.se, I can actually give you a link to that one.
yeah, I've got one. Let me put that up. I've got a banner for you. Let
And
me just.
on that one, you can find my blog post, and I mainly post about things around authentication, security, a little bit of Azure authentication, and things. So really think that authentication is interesting because it's something that most people are afraid of. So I really kind of like to learn the things that you know are complicated and other people might be afraid of. So that's my kind of my blog. Besides from that, so what are we going to talk about today? So really, it's good if you interrupt me if you have any questions, in discussion, ask questions. But the agenda for today is to talk about my cloud debugger tool and also about the default Azure credentials that I did a deep dive in for a month ago. So I will talk about that as well. So let's get started. So let's do kind of some background first, why I did all of this. So I wanted to get the AZ-204 certification. So that was my kind of summer project, studying for it, and because I've been in the cloud for quite some time, but really wanted to learn it, under the hood, really learn it, not just kind of click around in the portal and pray. You really want to learn how it actually works. So, how should we learn all of this? I mean, it's a pretty big certification. There's a lot of different concepts and topics and, concept and services to understand. So what are the kind of options here? Well, I could do the classic approach that, I do some, buy some Udemy class like Scott and Duffy's video, that's really, really good introduction. I could do MS Learn and go through all of that. I can buy some practice tests and practice. And of course, I could get my certification, hopefully, and I could get some notes. But actually, at the end, this is kind of something that you can put on your CV. Okay, that's good. My notes, will I really go back and read them afterwards? Probably not, because it's notes. It's kind of boring, maybe hard to read and kind of So there's no kind of value in my notes. So what did I do instead? So my philosophy of teaching and learning is that you don't understand something until you can explain it to others. So what did I do? Well, what I did was that I actually, started with, Scott Duffy's video, but at the same time, I studied. I actually created my own training material as well. So what I did was that. So let's show you some examples here. Break it, because if I'm forced to break down the concepts into smaller pieces and really kind of try to understand what it really means and how would I explain a specific topic to someone. So here I will kind of show you some examples, Cosmos DB partition keys. I mean, of course, a crucial topic if you really want to make a good Cosmos DB database. But if you don't understand the concepts, it's really hard. And if you go to MS Learn, it's a bit vague and abstract, and So I really kind of try to kind of talk about breaking down a Cosmos DB. Okay, you have containers, host data, and then you have documents in the database. Okay, that makes sense. And then you talk about partitions, and then you talk about logical partitions, and you go to do kind of physical partitions, and trying to break it down. How would I explain it to someone else? So that is what I did. So talking about partition keys, how things are spread out, and trying to kind of, I don't know, this kind of some stuff is of course not finished, and some kind of prototyping, but also why you want a good partition key strategy, because you want your data to be evenly spread out across the partitions and not like this. But we have to get that mental picture of these topics. So, I did this creating the material throughout my kind of studies here. And also I created a project because I really think that, to really understand it, sure, I can do the labs as part of this MS Learn, but we are really shallow and maybe not enough, I think, to understand the certification. So I did a project that I can go into in a bit. But the end result is that I got my certification. I actually got some future training material. And here I don't really know how to package it up because, it's the Azure is so big. How do you actually package it up in a way that makes sense to a potential student or company who wants some training? So that's my kind of biggest kind of question at the moment. How do I make something concrete out of it, and what would a company want? Because I really think that the official kind of MS Learn kind of PowerPoint and training class is not really the best, but that's a future kind of question. And I also got this kind of open source project. So as part of my studies, I created this project because I really think that having made an open source project is always a nice thing to have on your resume. It's a way to prove my Azure skills, and also as a way to learn all the concepts in
So you're a very hands-on learner. You're building training, and you want to understand all of the topics in depth.
Yeah, and I really think that the key is to look 1 or 2 or 3 layers below what happens under the hood, because just talking about Cosmos DB, but if you don't understand the partitions, logical and physical, then it will be really expensive and not so performant. Or just looking under the hood of any service, you really want to know how it ticks. So what did I write the project? Well, my project was because if we, for example, want to explore the planet Mars, how do we do that? Well, we are in a pretty early stages so far. But what we do is we send a Mars rover, a probe, some tool that can do kind of experiments, peek and poke, and measure the planet Mars to really to learn about it. And I think we need the same approach if we want to learn Azure Cloud. We really need some similar approach, because Azure Cloud is so big, it's unknown, there's a lot of danger, pitfalls, and and so what I did was to create my own kind of Azure rover, my own kind of cloud kind of debugging tool that I can deploy to Azure, and to really make experiments, peek around, look around, do experiments, talk to different services, and to really explore and learn Azure. So what can this tool do? Well, it's quite a lot. So, I mean, it's an ongoing project, but I have so far about 30 different tools that I can use to do various kind of things in the cloud. I can talk to Event Grid, Event Hub, and Blob Storage, and other things. And I can talk to, and explore some of those services to the right. And of course, not kind of 100%, but you can do a few kind of experiments that you maybe want to do to better understand how it works. Mm-hmm. So, and the question is, of course, so my idea was to make one application that I can deploy to all of those 5 different places. The exact same application I can deploy to all those 5 destinations, allowing me to compare, the behavior between app services, container instances, and container apps, to really kind of explore, if we have the same thing in all those places, then we can also make experiments and, play with things. So how do we deploy it? Well, the deployment story is so far that I do have a plain ASP.NET Core 8 web application, and I have some PowerShell scripts to actually do the deployment. And I chose, and you might come out, you should use Biceps, of course, if you wouldn't. But Bicep is not part of the AZ 204 certification, but the kind of AZ CLI tools and commands are. So I use the PowerShell just to kind of use the AZ commands to really kind of learn at the same time. So eventually I might do the Bicep conversion as well, but just as a disclaimer, I've used PowerShell so far. So I do have my scripts to deploy to all those 5 places, and also, of course, to the container registry, and then pushing it to the different container services. But also, while we're doing it, it's also an opportunity to really get into a more secure development practices. Because it's open source, I can actually start to use the features. I can use all the features in GitHub for cloud security and code security. So I use the GitHub Actions to build it, of course, as part of continuous integration, but also Dependabot to check for out-of-date dependencies. I use code scanning to scan for defects and bad code. I use the secret scanning to find if I accidentally deployed some keys into the source code. But not just that, I also introduced the Sonar Cloud as a third-party code scanning and code analyzing tool. And through that, I can also use Sonar Lint. That is a Visual Studio plugin that I can extension to Visual Studio that can talk to Sonar Cloud and also adds additional inline, type of reporting inside Visual Studio. So it's really nice way to kind of get to know all of these things and
I've used linting tools before, but I've never used Sonar Lint.
No, so Sonar Cloud is pretty nice. So if I go to Sonar Cloud website, I can actually go to my project, and of course I'm not logged in, but we can log in here, so it's pretty easy. So I do have my project and my cloud debugging tool, and all the kind of issues are we can see that the issues have been decreasing as I fixed things. And I can look at the full analysis. I can see it's passed. There's a few, let's look at the overall code. There's a few kind of maintainability issues. Now, of course, the classic to-dos, and some, make clean closing instance method static. That's just something I can look at when I, get back. But it gives me, additional kind of rules and tools to define, bad code, maintenance, and or maintainability and other things. So I think it was a pretty nice experience. Yeah. So let's look at the tool then. What does it look like? Well, it's basically an ASP.NET Core application. I'm not a designer, so it's a classic kind of style. But I do have here about 30 different tools. And of course, you can use the classic ones, like you maybe want to see what are my environment variables. I can see that. I can actually, if I want to, let's look here. So I can actually, if I want to, I can, deploy it. I can actually launch the 5 different, instances running Office applications. So if you see the link up here, we have, a temporary deployment to app services, Linux app service, and we have a container instance, and we also have container apps. So the same application, exactly the same thing, is deployed to all those 5 different places.
So was your idea part of the learning of 204 to figure out how to do this? You decided to deploy these to all these different tools?
Yeah, so I made it the same, as I showed you in the previous kind of picture here. I have the same application deployed to all those 5 different places. And, and I think that's the beauty of ASP.NET Core, that I can deploy the same code both as a container and to Windows and Linux app service. What I didn't cover is Windows containers, but I didn't see the need for that because, that's pretty rare thing, I think, to use. So I didn't do that. And then, of course, there's also the option to do Kubernetes. That should not really be too hard to add as well, but that's also beyond the scope of the AZ204 so I didn't do that. But it would be pretty straightforward. I mean, if I had an image in my container registry, I could just as well create a container, AKS cluster and deploy it there. But back to the tool. So I can, of course, do my environment variables. I can look at the kind of networking, what network interface can I see? Maybe useful if you're playing with like VNets and similar. You can see the kind of system details, kind of the server address that I'm listening on. What kind of operating system do I have? I can look at the local file system. So I can go to the file system here, and I can actually look in the C drive, for example. What files do I have? I can, go into the log files folder to see what do I have here. Okay, I was not allowed to go there. I can go to the C drive, to look at the different kind of folders.
Yeah.
And I can, go to the temp drive, and I can create a new kind of file, and I can create that thing. Of course, I didn't have access to the folder, so that's fine. But I tried. So I can look at, sometimes you want to maybe look at the file system. What do I actually have? And if you talk about app services, it also has some special folders like the application, you have a temp directory and your home directory. What do I see in each one? So, and what is actually deployed, for example. So that is, always a nice thing. But I thought, I'm not going to go through all the different tools here because that would be pretty boring. But let's look at a few concrete examples instead. So like the usefulness. Well, so let's say we have a user API gateway. We want to, we have an API in my Cloud Debugger. I wanted to expose it as /time in my to the public internet, but right now it does not work. So you might wonder, so we could go to the portal, we could go to the portal and we can look at the API gateway. So if we look at the API management service, we could look at that one. So I have deployed it already and I made some initial configuration, but it does not work. So I really need to know why doesn't it not work, because my goal is to talk to my REST API. So my app service on the /API/time exposes the current time. Pretty useful kind of endpoint. But if I go to the gateway URL and call it and /time, because that is what I want, but it does not work. So, and of course that can be a bit hard to troubleshoot, whether that you have this thing, you're not really sure about, how to configure your gateway. The time is deployed and configured, and I do have an internal backend API. But what I want to know is, did it call something here? What did it call? I mean, not maybe it did not hit this one. It maybe hit some other endpoint. Maybe I have some bad routing or revert or something similar. So what I can do in my debugging tool is I have a request log that displays all the requests made to this application, not just the kind of to the website, but also the internal ones, like the robots 933 here, that is made by the Azure kind of load balancer to verify that my service is responding. So I can even see those kind of requests, and for that I can see that actually the headers and the body for each request. So at the bottom here I can see /time. So apparently when just to prove that it actually works. So if I go back to my gateway here /time, call it again. Maybe I do it 2 times, and then I go back here. We should see 2 entries down here, and yes, we see it. So we know that we can actually reach my app service, but it would be really, really hard to diagnose without my debugging tool, because so, and of course we can fix the problem. So we need to go to the API, we need to look at my cloud debugging API, and we need, for that operation, we need to add some policy to let's see, to actually route it. So we need to here in the inbound do a rewrite to slash, API slash time on the back end. I forgot to do that properly. So if I do that, I save it, and now go back to my public gateway endpoint. We should see the time. So apparently it works now. But as an example of just being able to see all the raw low-level requests to my API allows me to actually, and now I can see that it calls the in my REST API. You can see the details about the headers that I received, and also the response that I replied back to the client in detail. So that's one thing. What else? Well, I could go to blob storage, and I could try to access my blobs. And I do have some keys for my storage account. So if I provide a key here, I can try to look in my blob storage container. I can have like a Azure reg.txt here. I can do a box. I can save that file, and that file should be you could go to the
container
storage portal and see that file if you want to, and we can actually do that just for fun. So because sometimes you just want to write something, you want to see does my key work? Do I have the rights? Do my managed identity work or something, or access keys or similar. So in my case, we see the Azure Greg file created here.
Very cool.
So that's good. What else can I do? Well, we talked about that one. We could talk about, okay, maybe you have events. You want to play with events. And when you do explosive events from a storage account, you create a system topic in Event Grid, and then you can make a subscription that published to a webhook. And of course, my Cloud Debugger exposes a webhook. So that actually works, because so what happens now is that if I now go to my debugger and go back up here, I have a webhooks thing. So actually I have 4 different webhooks kind of supported, and I can see the log for each one, and I can go to this one, and I can see that it actually created an entry here, put blob, Azure Greg.text.
Oh yeah.
And we can do that one just to kind of show you that and go to the blob storage again. We go back here, kind of I need to just go to Azure Rocks, and also need to provide my kind of access key. Paste in here. I save it. So we should see an Azure Rocks now.
Yep.
And if I go back to the debugger, look my webhook log, I can actually see the individual kind of events being posted as to my webhook. So I can see the headers. It also handles the webhook validation, because when you have a new webhook, you need to validate it, and my Cloud Debugger will actually respond to those validation requests. So it works, and it's compatible with both the cloud events and event grid schemas. And I can also, if we work with event hooks, I can also make the webhook endpoint fail. Maybe what happens if my webhook is kind of down, I can simulate that. So that's pretty useful.
That's useful, yeah.
Yeah, and what else? Well, I can send to Event Hub. I can do that simple demo here. So I can go to, for example, Event Hub. I can produce and send events to Event Hub. And of course, I need to provide some Event Hub, connection string. I want to send 10 events. And now I think there's also already a lot of garbage in my kind of Event Hub, but I send events to it. In this time, case I send 10 events. And if I go back to the consumption, I should hopefully see that, here's events added to it. I can see the partition ID, and actually I do display 2 partitions. So if I have multiple partitions, I can actually see what in each one of those 2 partitions, and I can see the offset inside the Event Hub, and headers and similar things. So I actually consume things from Event Hub. The last thing I want to show and talk about is, so let's say you want to play with scale out. Maybe you do want to scale out your app service, or maybe your container apps. You scale it out, but you're not really sure, does it really work? Maybe, you want to get a better feeling for that. So, so I could, not that one again. So what I do here, I have 4 different iframes, all refreshing, once a second or similar. So we see that, we're talking to the same instance in all 4 different windows. So, okay, that's nice. I could go to my portal. I could go to App Services. I could look at the Linux container, because we are looking at the Linux container kind of app service.
Yeah.
I can scale it out. So
have you set it to 4 instances just now?
Yeah, I can do that. 4 or 5 or 6 are scale out. So we can do that. You have to play with that. So because when you can scale out, let's make 6 like that. It's really, really hard to know, does it really work? I mean, what's the effect? Because if we let it deploy and we look here, we really see that, even if we're going to were to wait here for 5 minutes, we will not see any effect at all. You will receive exactly the same instance anyway, and that is because we have session affinity.
Right.
But if you don't know about the session affinity, the cookie, you would not understand that. Why is my why don't I see a random instance here? So because if I look in the browser, in the kind of storage, we see that we have this kind of affinity cookies, and those are set by the Azure App Service load balancer to ensure that I go to the same instance each time. So that that makes this kind of tool pretty pointless. But if I were to go back and use a different one that always clears the cookies, we would see here that you hit different instances each time. And that really shows me, my scale up actually works. So just because I really think that you need to have a mental model and a picture for how things behaves, what's different. And now I can really actually understand this in more better context than before.
This is really useful, because we have a customer where I work, and they have a .NET 4.8 app, and they are wanting to test session affinity with scaling. So this would be actually really cool to run on and then show them this.
Yeah. So, and of course, session affinity is good because, if you disable it, you will have, other problems with, cookies across services and data protection API and a lot of other headaches. But it's really nice way to show you what is actually happening. Does it actually work? And you can actually do the same thing with container apps. In this tool, it would work the same. And, so that's one thing. There's kind of tools for the caching. If you use the Azure CDN thing, there's the tools for local analytics workspace to actually send something to a custom workspace. Does it actually get through? I do have some example data already, just to show you, not that one. So I do have a workspace, and I have some logs in that one. So if I look at my table, there should be my application log, and there's an example of data I've written from my tool, just to kind of show you, I mean, when I write it, you know, what actually happens, what do I actually see, and I use different kind of severity levels just to play with that. So that's one thing. So this project is kind of open source. It's on GitHub, and I gave you the link before.
Yeah.
And you know, I made it for myself, but hopefully other people would find it useful too. So I would be happy to you know, get feedback. And I do have a lot of plans for additional tools for Cosmos DB and other services, and you know, fixing bugs and similar. And there's also an extensive wiki with documentations for the different tools, what we can do, and you know, talk about the different things, talking about, you know, event grid and, you know, use case, and you know, sometimes even how to set up your sample events grid, for example. So that is the cloud debugging tool.
Can I ask one or two really daft questions about this? If I have a web app, let's say I have a web app deployed, let's say it's my Festive Tech calendar website, what do I need to do to use this tool to point it at the Festive Tech, like Linux app service plan, for example?
Yeah. So what I have in GitHub. So if I go to my GitHub again, let's see if I can find cloud. So just to show you, so on GitHub, if you look at the code, I do have a simple actual deployment scripts. I have some PowerShells. There's even one, you know, build and deploy all. So that one will call, you know, build and deploy the kind of app services, and then I build and push the Docker image, and then I have a script to deploy to each container destination. So that's, you know, the easy script to deploy to all of them. But if you just want to deploy to one of them, you choose one of the scripts. And then there's one setting script that contains your kind of names, location, identity, and SKUs and similar for different services that is kind of used. So that's it. And, you know, I'm not a PowerShell expert or Azure expert, but, you know, I try my best to make, you know, a clean, you know, documented.
Yeah, that's good.
What's lacking is a kind of proper error handling, because the script sometimes fails, so I would need to add some kind of, you know, try catch or similar. But it's been working for me. And of course, when you're done by the day, you can just run the delete all resources that deletes the resource group for the debugger, and you know, there's nothing left. So it's very convenient to have. Besides that, you know, there's a Docker file that contains the Docker script for building it. So, you know,
you've got a lot of really cool stuff in this repo. There's a lot of cool, very cool tools in here. And how long have you been working on this for?
I started it for like 3 months ago, something.
Like that. That's pretty cool in 3 months.
Yeah. So, I mean, it's you know, it's always nice to get feedback, because, you know, I made it for myself, but will other people find it useful? I don't know, but I really think it's, you know, it's a nice way to learn, because when we want to learn Azure, sure, you can make some hello world simple things, but sometimes you want to explore, you know, my environment variables, what happens, or configuration, or caching, or error handling, or, you know, and other things. So that's, you know, I think it's pretty cool.
Other question I've got is, how do you get some of this information? Are you calling SDKs, REST APIs, Azure CLI? What? You got a mixture of all these different things?
Yeah, so it's a mixture of different things, because first of all, my application can, you know, query for the file system locally by itself, you know, environment by itself. And then, of course, if you want to talk to the different kind of services, I usually use the SDKs for the Event Hub or Event Grid. And sometimes I use REST API calls to like post to Log Analytics Workspace. And also, in some cases that I will talk about later on, I actually had to kind of do my own kind of hacked version of the Azure identity and HTTP logging to better suit my needs. And I will talk more about that in the next talk. But so I actually download the source code for Azure identity and actually created my own kind of implementation of default Azure credentials called my Azure credentials and in my kind of own kind of namespace, just to be able to add my own kind of debugging statements, and I will show it off in the next talk. So if you really want to go deep, sometimes you have to kind of be a bit unconventional and
Yeah, there's nothing wrong with being unconventional if you want to learn. Yeah, this looks really awesome. I'm definitely going to check this out.
Yeah.
What's been the biggest hurdle trying to get this running? Has there been anything particular like tricky?
I think the biggest struggle was actually to deploy it to Azure services using user-signed managed identity. And I actually did some blog posts about that thing. I actually spent a few, not a week, but many days trying to get that to work because it's really not so obvious. So in my interpretation is because when you do Azure App Services and containers, you have it under Deployment Center a separate identity. So that actually means that you have two identities inside your app service, and that is not really that obvious. First of all, it's not obvious, but your app has its own identity, but there's a separate identity to access your container registry. And the Azure CLI is not really good here as well, because I had to spend a lot of time to be able to set this one using the Azure CLI, and the documentation was actually buggy. I was in documentation and examples, and there was a lot of frustrations here. So I had to kind of resort to different approaches there, and I think I got it to work in a pretty nice way to actually get this identity using user-signed identity to work. But at the same time, when you try the simple approach, then you will actually get this kind of error for 2 to 5 minutes. And then if you see that error, you don't know if, is it deployment? Did the deployment fail or just working? That's really a bad user experience. So what I did was a different approach. I actually changed my approach. So I get this one first. So I know that, okay, it's not going to crash at least. I get some other friendlier message. And then, so I actually deploy the kind of, I don't deploy any image first. I just set entities, and then I change the container image for the real one, and then I get a much nicer experience. So that was the biggest struggle, It's but to get that to work in a nice, clean way. I also did blog how I did it using system-assigned identities, and that was a bit more straightforward. But I did a blog post that was about that as well on my blog. So, if you want to know more about that and the steps I took to get it actually to work, is outlined in my blog post. So, any other questions?
So you wanted to come on tonight and do 2 talks, is that right?
Yes, one is not enough. So, do you have some time limit?
No, not at all.
Okay, good. So, I could talk all day. This
so good.
But, I have to stop somewhere. So let's do the last one. So the same thing here, default Azure credentials. You see it everywhere, but how does it actually work? That's the question, and that is maybe not so obvious. So, of course, applications need to authenticate to access Azure resources. That makes sense, of course. But how can we authenticate? Well, we have two options. We can use managed identities in some way, or we can use some of the different access keys or SAS tokens or similar approaches. But of course, we prefer to use the identity approach if we can. I think we all can agree on that. But at the same time, how does it work when we use Enter ID? So, we first need to, our application first need to authenticate to Enter ID, and it authenticates using some credentials, managed identity, client credentials, or client secrets, or certificates, or some way. And so, but then the question, what's the desired outcome of this authentication? Well, the end goal is to get an access token. And using that access token, then you can, talk to your Graph API or Cosmos DB or storage account and get your data.
Yeah.
So that is a pretty similar approach to how a hotel works. So when you go to the hotel to check in, you go to the receptionist, and that is your Enter ID in this case. You authenticate, you get your key back, and then using that key, you can open your room, your room. And that is, of course, we all know how that works. But of course, the biggest challenge here is, of course, that, if you drop your key or it's stolen, anyone using that key can open that room. And, that's a concept called bearer token, but, that's, of course, you can do the various things to protect against this, but this is the kind of default kind of starting point, and that's beyond the scope of today's talk. But we have some challenges. So we have some challenges because that, first of all, we can have applications both inside and outside of Azure. Both want to talk to my resource, and we also want to use some unified approach for both cases. We don't want to have to kind of do different kind of code blocks for each one. So what else is a challenge? Well, we have many different ways to authenticate different kind of credential types. So that's another challenge. So the question of what credentials do exist in Azure? Well, we have quite a lot. All from Office Nation Code credentials to Azure CLI, PowerShell, client assertion, client certificates, client secrets, environment, managed identity, Visual Studio.
I'm having flashbacks to having issues with this kind of code.
Yes. We have a lot of different credentials. But then, of course, the question is, why do we need so many different ones? And what do they actually do? Well, all of them do, what they actually do is that they want to help you get an access token from Enter ID. And they will look in different places for that credentials. It might be in Visual Studio Code, it might be into Kubernetes, it might be in Azure, it might be inside PowerShell or your Azure CLI or your environment, in different places. So they will kind of look in different places for some credential and then try to get an access token from Enter ID. So, okay, that makes sense. So, and if we are developers, we have to use one or more of those kind of credential types to get the token. So, okay, so how do you do that in .NET? Well, if we use .NET here, then you could, for example, use the Azure PowerShell credentials. You create what scope do you want to access, and then you call the get token async on your credential, and hopefully you get a token back. Okay, that makes good. You could also try to use the SDKs directly. So if you use a blob service client, you can pass in a new Azure PowerShell credential type, and it will look in a PowerShell environment for some credentials and use that to authenticate to your blob service. And that's awesome. That works well, totally fine. But the challenge here is that in our code, we might need to use different credentials depending on where we are running our application. Is it on my machine, your machine, staging, GitHub Actions, or Azure DevOps, or in production in the cloud? We might need or want to use different ones for different places. And of course, having to write this kind of code, that's pretty kind of, boring and, error prone. So we want some better approach to this. So we have two special token credentials in Azure, or provided by the Azure Identity. So that the first one is the chain token credentials, and we have the default Azure credentials. That's two special ones. So let's talk about what's special about them. So default Azure credentials, what it does, it basically, is a big list of different token credentials. And when you use it, it will actually try one by one and try to get the valid token credentials. And it will come and go on until it works or fails. So when you use it, it will scan all of those credentials and try each one to find a valid credential and try to call enter ID, please give an access token. And if it fails, it moves to the next one, to the next one, to the next one. So that's really useful because the benefit here is that you can actually replace all of this code by using just default Azure credentials, and it will most of the time work just as well. So that's awesome because it will kind of try all of those different places until it finds one. So it means that you can replace all of this code with just this default Azure credentials, and you're done. And you can find, awesome. I can, skip all of this kind of code here, and we are done. But, and there's always a but, because there's some pitfalls here. So we need to understand how it behaves, because otherwise we might be in trouble. So let's say we run this code, default Azure credentials, but if I now do this in a virtual machine in Azure, I do not have any credentials, I'm not logged into Azure, I run this code on a computer without any credentials. What do you think will happen, Greg?
You'll get an error, obviously, you've got an exception. I've probably seen these kind of errors.
That is correct, but what else? So what I do here is I call this method 3 different times, and I measure the time. So each time I create a new instance of default Azure credentials, I get the token, and it will kind of fail, of course. But the interesting thing is that it takes time to scan all of those places for the credentials. It might take between 3 to 10 seconds before it succeeds. So that means that if you develop on a machine without any valid credentials, your startup time will be pretty slow. So it might take up to 10 seconds. 5, 6, 10 seconds. And then if you now do this in production and it does not find any credentials, maybe you have misconfigured something, then your startup time and will be a bit weird. So that's one problem. And if I were to do the same code locally, I do have a credential here, and if I do this, it would be, much quicker. So first time it takes like 1 second, and then it takes 12 seconds because it's cached locally, 8 milliseconds. So that's much better.
Yeah.
And so that is, something to be, careful about, because it might be a bit slow if you don't understand its behavior.
Mm-hmm.
But it's very useful as a beginner. It's useful because it allows you to, succeed more easily. And it will work in different places, hopefully. And also, if you want to, you can customize it. So if you don't use like PowerShell or Kubernetes, you can actually disable individual ones the startup time. That can be good to know.
Mm-hmm.
There's even some this one is actually disabled by default. Usually you don't need it, but it's available if you want to. So that's one thing. You can actually kind of disable things to improve your timeouts or worst case time. We also have a chain token credentials, and that one is similar to DefaultAzureCredentials, but you choose more explicit which one you want to use and in what order. So you can create any kind of combinations here and just include those credential sources that you actually want to use in your application.
So what would the reason be for combining like credentials 3? Why would you want to do that? What's a good example for that?
I mean, it's basically you want to replace all of this kind of bad code or ugly code with some more convenient approach.
Right.
And the DefaultAzureCredentials, we kind of try all of them,
Mm-hmm.
one by one. It will try them until it succeeds, and maybe it succeeds here. Oh, good.
Yeah.
But you don't maybe want to run all of them because they are maybe not useful, and because the challenge here now is that you do not know which one was selected.
Yeah.
You can't tell that, not very easily. So that's another source of problem, because you might end up with the wrong identity, meaning that you try to access blob storage and it does not work because you maybe have some test credentials here that was going to pick up. So that's the danger. So you maybe want to be more explicit about where do you look for credentials, because maybe you don't want accidental credentials somewhere to be picked up and used in production or during development, and you maybe go to the wrong database and it's all kind of crash.
That makes sense.
So that's can be a good thing to be aware of. And I think the key is that when you use a library, you need to understand a bit how it behaves, what's the abstraction, and what happens under the hood. And of course, back to the cloud debugger, because DefaultAzureCredentials is not really transparent. You can't actually see that much about it. It's pretty black box.
Right.
So that's pretty sad. So I fixed that,
Oh, nice.
So what did I do in the cloud debugger is I made, first of all, a DefaultAzureCredentials. I can actually run the debugger locally first, just to show you the same tool locally. So if I start it up, let's see. It's not always the fastest. Yeah. So if I run this locally now, and I have a tool for DefaultAzureCredentials, I can get an access token. So I do that. and it succeed. I get an access token that is kind of valid. It expires in like 59 minutes. I can see that, and that's good. I can actually copy that access token to jvt.ms to look inside that access token. I can see all the details, and also I like these kind of claims tab here that actually explains all the different claims inside the access token, because some of the claims here are kind of Azure specific, some are more standardized, so I can actually get an explanation of what's inside my access token. So that's pretty useful. I can see it will tell me which credential was chosen. I can't see that by default, so that's why I hacked the default Azure credential, because I wanted to tell which one was actually selected. And this case, I use the environment variables. So I do have a client ID and a secret, and of course I do hide my secret, and tenant. And also it tells me based on, so this is kind of log statements I made in the token credentials classes themselves. So I modified the Azure SDK to log the details. So it tells me based on a provided environment, it will either choose the client secret credentials, client certificate, or username password credentials. And it selected the client secret credentials based on the provided data, so that's good. But it also tells me which one are part of the default Azure credentials, which one, are part of it. So I can actually see the log from each one. I can see, they haven't been executed because this one, the first one, did find one, so this one didn't run. So that's good. But if I do the same thing, if I go to the cloud version and do the same thing, get an access token. So this time I don't use the environment variables, I use a managed identity. So we see that the selected token credential is a managed identity credential. It tells me details about how it got it. It talks to some internal endpoint, token endpoint. There's a client ID, there's a secret that I do hide, and also some of the token I received when it expires. So this one expires in like 1400 minutes. And I also can see that, so this time the environment did fail because it did not find any environment variables except the client ID that it did find. We tried the Kubernetes, did not work. We tried the managed identity, and eventually we got the token, so that's good. And then of course the other ones did not try. And I also show a more in-depth kind of log of the different things, and also shows the kind of default retry policy in case there's some kind of timeout or similar. But still you see it. So still we use a managed identity. Okay, that's good. But maybe the question is, how does it actually get the tokens under the hood, really low level? So I can actually go up to the internal event log and see all the identity requests being made, where it kind of calls the different endpoints with different stuff there. So it really kind of show you internals, even one layer below. So you can actually see that kind of it fetched access token from a host, blah blah, and another kind of details, and I guess there's other things as well to write there. And then you can actually see the request that was being made to the, so if you zoom in a bit, you see the request being made to the Enter ID service, and it gets back the kind of token, and and really kind of low level details.
Very cool.
So that's nice. Another thing that a few more things. If I go back to the identity part, there's also caching. How does it actually cache the tokens? So let's say I run this code. I do create an instance of DefaultAzureCredentials, and then I call get access token 10 times. So you might wonder, okay, so attempt 1, it takes 200 milliseconds, and then we get a cached response, and each time you see the same kind of tokens, same checksum. But if and this actually shows the chosen token credentials and sample access token. But if I try to do a new instance each time, does it affect things?
Yeah.
So locally, we see that each time, the time it's take about 100 milliseconds each time. I get a different token each time. So clearly, it's not cached.
Yeah.
So and shows a sample access token. But the question is it the same behavior in the cloud or not? So I can actually go back and do the same caching in the cloud. We see that, okay, the first approach is cached. We get the same access token back. The time is really good. It's locally. And this time I use the managed identity credentials. And the second case is also the same, also cached. So the conclusion is that different token credentials will cache differently.
Right.
And that might also affect performance, because if you have to look up each time for a new access token, a unique one, that will take time. So that's clearly an important thing to be aware of. And also you can try to, another tool to I want to just play with the kind of developer CLI. I want to try the managed identity. I want to play with Visual Studio. I want to call a specific one in the cloud or locally. I can also do that and see what happens.
Yep.
So that can be useful too.
I will be sure. Yeah.
And also, of course, on the site and at the bottom of each page, there's a link to the documentation for the corresponding tool, and trying to get some more documentation. And of course, this is really kind of dangerous tool, because it shows, it exposes things that you're not maybe supposed to see, access token, secrets, and other things. So it's really a dangerous tool. But finally, what I also find is useful is that it tells me when was it built and when did it last start. So I know that if I deploy it, what I expect, because it's hard to know, did the new version was it deployed or not? Did it restart and when? So I can actually see, a quick kind of glance here, when was it last deployed, and what build, when was it?
Yeah.
Because otherwise it might be really, really hard to troubleshoot, the deployment doesn't work. Is it done yet? So I think that is also, many times it's all the small details. So that is also too. And I could go on here about more things, but I really think this is the kind of my agenda for today.
Yeah, no, brilliant. I mean, you must have learned an absolute ton of stuff building this.
And of course, feel free to follow me on LinkedIn, and also try out the cloud debugging tool. Check my blog post. This post about Azure and authentication and security, and let me know what you think about the tool. And I'm a trainer, teacher, and if you want some training in the .NET or security or architecture, I'm available.
Very cool. Yeah, I've got a couple of questions, I guess. Yes. How much do you think you've learned building this? You must have learned. So when you finished, did you finish building this and then take the exam, or did you take the exam in the middle of building this, or
I did the exam in the middle because, when you later want to kind of go public and do an open source, you really want to polish it. You want to have documentation, and so that's been the kind of the last kind of weeks of work getting the documentation and clean code and well documented and well structured, and all the warnings removed, because you really want to show good clean code, of course, not some lot of hacks. So that's a lot of time to polish, and I do have a backlog of additional tools to add to it that is not maybe ready yet or in a polished state. But I really think it's a good platform also for learning. So if I do a training class in the future, it can be a good kind of training platform to do, because most of the time you need to verify things. What happens when I do a scale out? What happens with my environment variables, or what happens with my settings or configuration, or I want to explore event grid. I want to, publish to and from the event grid, or event hub. Or I also have things for service bus and actual storage queues and coming up as well, and other services, or the proxy, the API gateway. So it's all about trying to help you to build a good kind of platform and framework to base exercises around. Because you sometimes need more kind of a starting point, and doing it all by yourself from scratch will take quite some time.
Yeah. Last question, I think, Tor. How did you find the exam? Did you find it quite easy because you had spent a lot of time building this and you kind of had a lot of in-depth knowledge, or were the questions a little bit too high level?
Yes. So I actually have a good picture of that. Let me see if I can find that.
I'm going to guess you smashed the exam.
Well, I actually made a good picture, but I really kind of represents my opinion on it.
All right. Okay.
Just a minute. Yeah. So I really think that maybe Scott Duffy's course is a good video, and everybody recommends it. And then you take the MS Learn. But to pass the certification, you really need to go beyond the MS Learn, because the questions in the certification is really way harder than MS Learn. So you really need to kind of go deep and to do. So that, I think, is a good kind of my observation, that you really need to go one layer below MS Learn.
Yeah. I mean, I think, to be honest, I've probably passed some exams just doing like a Scott Diffie course, and then doing the MS Learn, and then taking the exam on a topic that I don't really do day in, day out. So I've kind of done that and passed the exam. But like, if I was sitting in an interview on these subjects, I would probably struggle on some of them. So but the in-depth stuff is like the Azure DevOps 204. What was it? I can't remember the exact number.
400.
Yeah, I went deep like you did. I deployed Azure DevOps pipelines. I deployed GitHub Actions. I deployed all of that in hands-on learning. So I get why you did this, and hats off to you, because I bet you learned a lot of stuff.
Yeah, I also did AZ900 earlier this year as a way to get familiar with the certification process and kind of how is it kind of test organized them as a warm up. So I always think it's good to take this one, even if it's a lot of kind of marketing maybe.
Definitely.
I think it's a good kind of warm up to any certification. And I also found the Reddit group was also helpful to get some ideas, and people explaining how they taught or failed presentation. So I think that one was good as well. So that's really a good kind of point.
Very cool. Listen, Tor, thank you for coming on. My last question to you is, before you go, I want to mention the Festive Tech calendar. So I'm hoping you're going to you're going to put a session in for my festive tech calendar. If you're not, I'll be disappointed.
Yes, I have to check it out,
Yeah, so they sessionizes that. So basically, if you don't know what the festive tech calendar is, just for anyone who's watching, in the whole month of December, you can write a blog post or a video on any tech subject that you want, and you will always get accepted. So we don't reject anyone.
Okay.
And throughout the month of December, we will put all of these blog posts or videos up, and we'll do a little intro, and we'll do a little video, and you'll get a nice little thing to put on LinkedIn or Twitter to say I'm taking part in the festive tech calendar. And part of this is we're raising money for a charity in Glasgow called the Beatson Cancer Charity. So we do this every year, and if you can put a little festive spin on it, even better. So if it's Christmassy or music or I don't know, something festive, then even better.
Okay.
Yeah. Awesome. So
one thing. I also have if some of your audience live in Skåne, I actually have my own. I'm of a meetup called .NET Skåne. That's kind of south of Sweden. So if you're in Sweden or Denmark or close by, we have a monthly meetup, and next time is together with Dev in November. And
is that in person? Is that in person or is it in person and remote?
This is all in person.
In person. Good.
Yes.
Awesome.
So
and how is it? Is it once a month? Did you say?
Yes, about once a month. So.
Very cool. Very cool. Yeah, thanks for showing us that. I'll definitely punt that in my. Remind me to mention that in my newsletter.
Yes, I will. Good. I'll send you a link.
Perfect.
Nice speaking to
you. Thank you for coming on. Thank you for covering both topics. I learned quite a lot on the default Azure credentials. I'm going to use your tool because I've actually been trying a bit of .NET code recently, and it basically comes back and says there's no credentials found, and I was like, don't even know where to begin with that.
Yes.
So I can use your tool and at least try and look at the code and figure out what it's doing. Yeah. So that's awesome. I can also demo this for a customer they need session affinity turned on, and they need to make sure that when a user logs in, they always go to the same instance. So I can use that tool to show them that as well, which is very cool.
Yeah.
And that's really the end of tonight's stream. Once again, thank you very much for coming on. Stay on the stream, don't leave. I will click end stream, and then I'll say hello. I'll chat to you before you go. But thanks for watching, everyone, and I'll just click end stream.